Welcome back to our MATLAB machine learning series. In the previous video, we split our data into training and testing sets. Now, we're moving forward to the next crucial step, converting data and extracting features. In this part, we will convert our data into tables with meaningful column names, convert the label column into a categorical type, which is essential for classification tasks, write a custom function to extract features from our URLs, which will be used later to train our machine learning model. Let's get started. We begin by converting our data into tables with meaningful column names. This step organizes our data, making it easier to manipulate and understand. Additionally, converting the label column to a categorical type is essential because MATLAB's classification algorithms require categorical labels to distinguish between classes effectively. As you see, we are using the cell to table command to convert our data into table format. We specify column names as URL and label to make the data more meaningful and accessible. Next, we convert the label column into a categorical type. This is crucial for classification tasks as it allows MATLAB to identify and differentiate between the various classes present in our dataset. Our data is now organized and labeled. The next step is to extract features from the URLs, which will serve as inputs to our machine learning model. To do this, we'll create a new function that systematically analyzes each URL and extracts relevant features. We start by defining a function named URL feature extai that takes URL names as input. This input is expected to be a list of URLs from which we will extract relevant features. The function will return a matrix containing these features. Since URLs are typically stored as cell arrays, we convert them to string format using the string function. This conversion allows us to easily manipulate each URL character by character. To extract features efficiently, we pre-allocate arrays for each feature we want to extract stores the length of each URL, counts the number of letters in each URL, counts non-letter characters such as numbers and symbols, counts the number of dots in each URL which could indicate subdomains or file extensions, counts the number of reverse slashes in each URL, counts the number of hashtags, which are often used as anchors in URLs. We then use a for loop to iterate through each URL. The first feature we extract is the length of the URL, which can be an indicator of malicious links, as phishing URLs are often longer than legitimate ones. Next, we check each character to see if it's a letter using the isLetter function. We then sum up all the letters to get num letters. The non-letter characters are calculated by subtracting the number of letters from the total length of the URL. We then use the strFind function to count occurrences of special characters. Reverse slashes are commonly used in complex URL structures. Hashtags indicate anchors or fragments within a web page. Dots often indicate subdomains or file extensions. To keep track of progress, we display the percentage of URLs processed. This is useful when working with large datasets. All extracted features are combined into a single matrix and returned by the function. This matrix will serve as input for our machine learning model. Save the function as URL feature extai.m in the same directory as your dataset to avoid path issues. We then call the URL feature extai function to extract features from our training and testing datasets, which will be used in the next steps to train our model. To summarize, we converted our data into tables, created a feature extraction function, extracted features from our datasets. In the next video, we'll use these features to train our machine learning model. See you in the next tutorial.